All right, so let me hide this. All right, so a couple of things I would mention. Sorry about the issues with the online homework platform. It should be working now. You should be able to register okay. I looked this morning, there was a little bit more, like a third of you who got on there and registered and signed up. I did forget to mention there's like a 2-week kind of trial, free trial access you can also get. And then you can buy it later on if it syncs everything up. So that's an option you can do. If you're having some issues with it, one thing I think, is instead of clicking on the homework, going down here to this My Lab and Mastering, and then you should have kind of this prompt where you can open it in a separate, it'll like pop up as a separate page, and kind of registering that way might be a little bit easier, or might not present challenges that it would if you just clicked on that homework assignment that shows up as that first homework assignment. The other thing that I wanted to mention about the first homework assignment was, so for this first one, I've got this thing where you can like check your answer. So you can kind of keep taking attempts to make sure that you're getting it correct. Well, I threw a couple multiple choice questions on there. So if you really wanted to, you could go through, get the right answer, and just not really focus or pay attention to what you're doing. On future assignments, I'll turn that off for questions that are like multiple choice. Obviously, some of the ones where you happen to enter a number or do some graphing, there's an infinite number of numbers you could guess. So I don't care if you check your work on that, because you can't just nail it in and just guess until you get the right answer then. So future assignments, I might have that check your answer tool turned off on some of the questions, especially if they've got multiple choice, if they're just multiple choice, right? But primarily I want to use this for like graphing and kind of working out some equations. And so it's got some questions kind of built in to where it like gets you used to using the graphing tool, and then kind of progresses into actual material we'll start covering today and tomorrow. Okay. Any other questions from me before we kind of get going? So we start talking about kind of some of the principles that we might be talking about throughout the semester. So one of them is optimization. So this is basically the fact, the idea that we've got, seriously, we've got these constraints. Might not everybody can, have all the goals they want. There's only a certain amount in the world. And so what is it optimal for society or the world or an individual to do given some of these constraints? We also talked about things like opportunity cost. We said that was the value of the next best alternative, right? Or what was given up in order to do the specific activity we're looking at. And we'll walk through an example there with like rental decisions, I think I mentioned last class, right? So the idea if you call off work to go to a free concert, it's still not free because the cost is whatever you could have made at your job. Right? This is an example I kind of gave last class as well. I don't know, I found this new. I thought this was a good one to kind of get the idea across too, right? The biggest opportunity of going to class, opportunity cost of going to class is, Netflix, right? You're not able to then watch Netflix. I think I gave that example last class as well. So, a lot of what we do in this class is really going to come down to, we're going to try to determine what the costs and what the benefits are. And then essentially, what is optimal for someone to do? Well, it's optimal if the benefits making that decision outweigh the additional costs to making that decision, right? So that's kind of cost benefit analysis. That's really what you could boil down most of especially this principles microeconomics course. You could boil it down to pretty much that, right? We're trying to determine costs and benefits. Now, sometimes it's to a person, sometimes it's to a company. It looks a little bit different, but ultimately we're just trying to assess what the benefits and the costs are of different decisions. So equilibrium is going to be another term that we use. And this is basically that every person is benefiting the most from whatever their current behavior is, right? And that no one person could change their behavior to be better off. So we got to think about what equilibrium looks like. This might be something like at current prices, a certain comedian or a specific band is selling all their available tickets, right? At that price, the equilibrium is all tickets are sold. Well, maybe if they double the price, the new equilibrium for some people, they don't value going to that comedian or that musical group that much, and so they instead decide not to buy tickets, right? So, for instance, I was thinking about going to the Colts. Unfortunately a Detroit Lions fan. I was thinking about going to the Lions Colts preseason just to, I thought it'd be really cheap. I got on, looked at the prices when they first came out, and they were still like $50. There is no way I'm going to pay $50 with a preseason game. They don't even matter, right? And so there, the equilibrium, if they keep the price high, might be that no tickets are sold. Well, once the initial tickets are, come out, start looking, sure enough, you can get some tickets for like $5. Now, if the ticket is $5, I might decide to go to that preseason game, right? So at a lower price, maybe the equilibrium is that they sell all available tickets, right? So we're looking at kind of what the resulting outcome is of these different pricing decisions, right? And whatever the resulting outcome is, that's the equilibrium number of tickets sold. So that's kind of the idea. Another one, you can kind of think about grocery store lines. So let's talk about like the equilibrium. If I walk up, and there's like, for whatever reason now, you're in Meyer, there's like 40 lanes and 4 of them are always open, right? And so I look at the 4 lanes that are open. One of them's got 6 people, one of them's got 4, one of them has 4, one has 3. Which one am I going to choose? Assuming they all have about the same items, I'm going to go over the one that has a 3, right? That's the optimal decision for me. Well, then the next person come up behind me, now it's 6, 4, 4, and 4. Well, they don't really care. They choose one of the lines that has 4. Now it's 6, 5, 4, and 4. And that keeps going, right? Until maybe we get to every line has 6 people, right? And so this idea of kind of equilibrium is that it takes time for that equilibrium to play out. So sometimes if we set a price, it's going to take time for us to see what the equilibrium number of tickets sold might be, right? But eventually, like over time, we'll see kind of at that price what the number of tickets purchased, ends up being. And we'll have a bit of a discussion about long versus short run along the way when we start talking about equilibriums. But this is kind of the general idea, right? People are just making the optimal decision for themselves, and that results in some final outcome given, the current prices or kind of the current situation or circumstances. I'll go through this pretty quick because I'm not going to hammer this too much. We won't do a ton of empiricism in this class, but as you progress, if you were an econ major, you really in your classes, we'll start doing this is we'll have these questions. We'll see kind of what the optimal decisions are, potential equilibriums, but we might have questions that we then want to test with data, right? Theory is great, right? When we theoretically can predict certain things, but if it doesn't play out in the real world, well, then that theory is garbage, right? So I'll give you a pretty good example of this, right? So in this one, I've got some questions here. I'll focus on the second one. So how many fewer gallons of gas does an average person buy if price goes from, fell from, or went on? Can't get this backwards. Shouldn't be fewer gallons, right? It shouldn't be fall. It should be rose. All right, so if and then it wouldn't be, here we go. Let's make this make a little more sense. I might have typed these up a little bit too fast. So let's say the price goes from $2 to $3, right? How many fewer gallons is someone going to buy, right? You make gas more expensive, people might buy less. Right? I think that's a fair kind of idea. So we generally think about the theory would predict that as prices go up, people buy less of a good. That's the theory. But there ends up being this really weird behavioral thing that for some goods, people actually buy more of them when the price is higher, right? And that's because they're using that price. So if I go on Amazon and I'm searching for something, generally I can find a really cheap, crappy version, right? If I got to look at the reviews and maybe I've realized, oh, yeah, the cheapest one has like 2 stars, right? But if I couldn't see those stars, I might just look at the price and say, well, I don't know, this t-shirt's $8, this one's $16. They look pretty similar. That probably means the $16 shirt is maybe a little bit better material. Maybe it'll last a little bit longer. So sometimes people will use price as an indicator for quality, right? And so there, maybe having a higher price could actually end up resulting in more people buying your good if they want a higher quality good, right? So we've got the theory, but sometimes we'll go out and look at the data and see people actually aren't following that, right? And then that leads us to investigate, okay, well, what's going on? And then we have this idea that maybe they're using price as a signal. So empiricism is we go and look at some actual sales data, right? So I'll try to show you some data along the way. If, along your progression in your degree, if you're within the college of business, you'll have to take 221, which is business statistics. That really focuses on empiricism, right? Using data to actually verify whether or not these predictions we're making with the theory actually are true. So another kind of example to throw this all together would be something like, what's the optimal decision for people to do when it comes to whether or not they live in college? Well, we can build a model, right, that says that as you accrue additional education, you can expect, like, why do people pursue education? I mean, some level of knowledge, I guess, but most people, especially within a business college, you're probably thinking that you're going to make more money than if you didn't attend, right? So the basic model is that as I increase my education, as I obtain this college degree, it will potentially result in my income being higher. Right? That's the prediction. We could then go out and collect data on individuals who did attend college, collect data on individuals who didn't attend college, look at what their incomes are, and then compare the two and see, is the group that has a college education actually earning on average a higher income? Right? So that idea is we have this model, this prediction of what's optimal for an individual to do, attend college to increase income as long as the cost of college isn't greater than the additional income they'll get. We then can go out and empirically look at the data and see whether or not that prediction is true. Right? And on average, it is, but we're talking about averages. So one thing in this class that we always have to remember if we're comparing averages, making generalized statements, is we're making general statements about the average person. So on average, an individual's wage is higher if they have a college degree versus not. But if you look at some college dropouts, right? Bill Gates is making way more money. Mark Zuckerberg way more money than people who have graduate degrees, right? And so there's always going to be individual exceptions, right? There might be someone who didn't attend college who makes more money than someone who did. But on average, empirically, the data tells us that on average, the individual who attends college will expect to make a higher income. So there'll always be kind of individual exceptions, but we're just kind of thinking about making predictions on the average, right, or for the average. Let's talk a little bit about correlation versus causation. This isn't too much in this class. We'll have a little discussion towards the end. But just to the idea, correlation means things move in the same direction, right? And so, it's one way we can think about it. So we look at ice cream sales and child drowning deaths. Those two things are highly correlated. They both increase kind of synonymously, or they both decrease at the same time. But that doesn't necessarily mean ice cream sales are causing children to drown, right? They're getting too full, tired, and they drown. No, that's not what's happening. What isn't getting factored into this kind of equation that you stated? What causes higher ice cream sales? Probably warmer weather. When do we probably see more child drowning deaths? Warmer weather when pools are open, right? So it's this third outside factor, right, that's causing both of these things to increase. So just because we see two things be correlated doesn't necessarily mean one is causing the other. Could be this third outside factor that's causing both of them. Okay. All right. So kind of building all this idea of just talking generally about kind of decision making, let's go through something and maybe actually calculate some opportunity costs and think a little bit harder about this. So let's say I've got 3 apartments that I like equally. I think my prices are probably going to be ridiculous compared to what actual prices probably around here are. But just to use some basic numbers, that's what I come up with. So we've got 3 apartments, right? Each one has kind of a different rental price. And what we're going to assume for this example is every apartment is exactly the same, with one exception, which is where they're located. Okay. And we'll assume that the locations are not, the neighborhoods are relatively the same quality. It's just that they're further distances from the university. Okay. So we've got 3 different apartments, right? If they're all exactly the same, and I don't have any more information about them, I don't know how far away they are from campus, but I know it's the exact same apartment, but there's 3 different prices. Which one of these am I going to choose? The one with the lowest cost, right? So if I'm getting the exact same apartment, let's assume that they were in the exact same location. I'd for sure choose apartment C, it's the cheapest, right? But what if each one of these apartments is a different distance from campus, right? So, I don't know, let's say 5, 10, 15 minutes away. I forget, I calculated this at one point, like how many times you'd have to walk to campus, and came up with, over a semester, that's gonna, or over a year, that's gonna add 12 hours of walking, 24 hours of walking from apartment B, and 36 hours from apartment C, or walking or travel time, however you want to think about this. Well, that travel time has value, right? And so if I'm thinking now, well, the cheapest apartment is also the one that is going to take the most of my time throughout the year. And so can I value that time? So kind of a crude way to do this, and obviously the way it plays out, every 15-minute walk wouldn't necessarily mean you just went into work for 15 minutes, but we can put some type of value on people's times. And probably the easiest way to at least start talking about it is how much money you could have made if you were working during that time. I think that's the easiest opportunity cost to understand. Now we could say, walking these 15 minutes every day, I'm giving up the value of sleeping 50 minutes more, and I would pay X amount of dollars to sleep 50 minutes more, and we could actually put a value on it that way, right? Like 15 minutes of extra sleep is worth $10 every day, 36 hours, multiply that, we can do it that way. But for this example, we'll just use kind of hourly wages that you could have earned if you were able to work those 36 hours that you had to give up. So that's going to help us put a value on how much time we're spending traveling. So let's assume, I have this idea of opportunity cost. We've already talked about this, so we won't have to we talked about the concerts and things like that. So let's think about if your time is valued at $10 an hour. I know it's above minimum wage, but probably it's still kind of low for a lot of jobs. But let's just assume, to make the number easy, that you can make $10 an hour. Okay? So we could then take that value of time and come up with the opportunity cost of selecting every single apartment. Because the total cost is not just what I'm paying in rent, but also how much, how much is the time that I'm giving up every month value. I'm sorry, when I said that calculated semester, now I'm realizing those times were how much you lose every month, not the semester, right? So we've got a rental decision, a monthly fee, and also kind of how many hours we're giving up each month from traveling from these different apartments. So for each one, we have the time we would spend every month traveling. We can put a value in that because every hour is worth $10. So if I'm giving up 12 hours, the value of those 12 hours would be 12 times 10. Right? I could have earned $120 additional that month if I could have worked all 12 of those hours. And then what about the 36 hours? Well, if every hour is worth $10, total cost of the 36 hours would be 36 times 10. Right? I could have earned $360 additional if I could have worked during that time that I was traveling. So we now have the explicit cost of the rent, right? I think it was what, 1,800 and 700 or something like that. And I now have the opportunity cost of what I'm giving up. So to get the total cost of choosing each one of these apartments, I need to add those two together, right? So I'll take the opportunity cost of every single apartment, of choosing every single apartment, add in the rent, and now I've got prices. Now, if I'm thinking about the overall cost to choosing each one of these, which one has the lowest overall cost, which factors in not just the explicit, but also this opportunity cost. Now it looks like apartment B is optimal. Okay? A little bit more expensive, but it saves me some time. Okay? Now just barely, just a little bit lower, but it does kind of switch my optimal decision there. Right? Once I factor in these opportunity costs, we can sometimes, we realize the optimal decision might be different than if I was only using the explicit cost of just the rental rate. Any questions on this? I'll think a little bit more here about this. So what if time was valued at $20? So when your time was valued at 10, right? It switched our optimal decision to the apartment C, the one that was cheapest, but the furthest away, to be the one that's a little bit more expensive, but closer. I don't have to give as much time traveling. If time becomes even more costly, which apartment do you think becomes even more attractive?
It's the same.
So if the time is valued more, remember, how are we coming up with the opportunity cost? Whoops. We were taking how much time we had to give up, which will remain the same, but each hour is worth $10. If now we can go out and work for $20 an hour, each hour is now worth $20. So the apartment that's going to become even less attractive would be C, all right? The less attractive would be the ones that are further away. Because now that same 36 hours that I have to give up, it's not worth just $360. It would be worth twice as much, right? 360 or 36 times 20, right? And so we could think about if we had time valued at $20 an hour, well, now the opportunity cost becomes really high for these apartments that are far away from campus, right? And now when I factor in these opportunity costs, it's probably going to push me more to choosing that apartment that's really close to campus, right? So now if we look at the overall cost, right, we factor in the new opportunity cost from the higher wage that we can now earn and get a raise or something, right? Now it looks like apartment A is actually the optimal one to choose. So this is exactly, you know, if you think about why do people have apartments in New York City that are like ridiculous amounts of money? Well, those people are probably also making ridiculous amounts of money. And the further they live out from the city, if they have to commute in an hour, hour and a half, their time is very valuable. If they can work an additional hour or two a day, they could make a lot more money, right? So it may be worth it to them to be closer to the city, to be in the city, so they don't have to have all this travel time, which is really costing them money they could be earning at their job, right? So instead of $20 an hour, you know, maybe it's a couple grand an hour for some people, right, depending on their position. So I always thought this is kind of a nice toy example. It kind of applies to, I guess, rental decisions. You know, if you're looking at something, at least when I was in college, like I didn't necessarily think about it, right? Like I didn't explicitly think, well, yeah, the more travel time, it's going to, you know, going to cost me the time to work. But you do know the further out you live, the more time you're going to have to spend traveling, and like you would pay not to have to do that, right? Which is why you might choose something that's a little bit closer to campus where you don't have to travel as much. Now, you may not like write down the opportunity costs, right? But that's how you're thinking, right? You know that there's an additional cost to living further from campus, even if the rent is a little bit low. Especially if like, you know, I guess in the college example, you've got some free public transportation, but especially if you're having to pay for transportation, you're like you're in a city where you're paying the Uber, or you're paying the taxi. There's some cities that sell taxis, right? But that's the general idea. Questions on this? Okay, so I think I ignore the floating box. I must have add animation to those. So we'll just look kind of cool for a second. So we're going to start thinking about marginal costs now. Right? So we can think about total costs, right? If I, you know, I'm currently producing 1,000 units, maybe that costs me $1,000 every unit is $1. But what's the additional cost of producing one more unit? Well, if every unit costs $1, my marginal cost would be if I produce one more unit, I'm going to add $1 more to my total costs. Right? Now, if I'm producing 1,001 units, my total cost is $1,001. But the marginal cost of that 1,001 unit was just, it added just $1 to my total cost. So marginal, right, means essentially how much is being added, right? So by increasing by 1 unit, how much is being added to my costs, right? How much are costs increasing by, okay? So we can think about this not just in terms of production, right? But any decision-making process. So what's the marginal cost as I move further away from campus, okay? So I can't remember, let's see. This must have been when my wage rate was $10 an hour. So we go back to those numbers. We had computed the opportunity cost of commuting. We had the original rental rates. Well, we can think about if I was calculating the marginal cost, right, from choosing apartment B over apartment A. Right? Well, if I was to choose apartment B over apartment A, right, I'm actually paying $200 less. Right? And if I choose apartment C instead of apartment A, I'm actually spending Jeez, I should check my. There we go. So this one's not $100 less. This is $300 less. I meant to add those two values together. There we go. All right. So the marginal rental cost here is that if I choose apartment C instead of apartment A, I'm spending $300 less, right? Remember, the additional costs would mean that if I make this choice, how are my costs changing? Well, here, they're not going up, they're actually going down, so that's why we can have these negative cost values. So generally, most of the examples we'll look at, our marginal costs will be positive, like choosing to do something is going to increase my cost. We'll start talking about more like production decisions. So if I produce more, it's going to cost me more. But occasionally, we have some situations where making a decision will actually decrease my cost. So there, the marginal cost would be negative. In fact, we're talking about things like economies of scale that sometimes even in producing more, we might see that kind of additional cost will decrease. So we look at commuting costs, all right? We kind of think about in choosing option B over option A, right? The additional commuting cost would be $120 more, right? My commuting cost would go from 120 to 240, right? So there, the additional cost of choosing option B will actually increase our costs. And then we kind of have, if we looked at the total cost, where we added the opportunity cost of commuting to the rental rate, we can think about if I choose apartment B instead of apartment A, right? The additional cost is actually cheaper, so negative $80. And I could do this when I had the wage rate of $20 and, I could play around with different numbers, but that's generally the idea. Once we had these opportunity costs and we factor those in to get the total cost, we can think about kind of the marginal, the additional cost from choosing one option over another. Yeah.
Would it be 1,049?
Oh, no, I forgot a zero there, didn't I? What was that? 10,000?
And then, on that other.
This should be 10,000, right? So if I go back here, where was it? Right here, right? Yeah. So these are all 1,000. I see what you're saying. Not 10,000. These are all. There we go. That's better. Yeah.
One question. On the marginal cost, were they all
Yeah.
supposed to be 120?
Hold on. Let me have them all displayed. Where?
Right there, are they all supposed to be 120?
Here?
Yeah.
Because it's just the way that the numbers I used, right? Because I had it like kind of like doubling the difference between 120 and 240 is 120. Here I'm thinking about if I chose option C instead of option B. Okay, right? So the marginal costs are computed by comparing to the department right above it. Okay, right? Yeah.
So then I think you're negative 100 for that first column.
Oh, yeah. I tricked myself into it, didn't I? Yeah, sorry about that. Thank you for pointing that out. All right, so let me clarify. These marginal costs, they actually were in the track. So it's always comparing to if I chose option B over option A, and if I chose option C over option B. So when I'm looking at the total here, if I'm currently in apartment A, would I choose apartment B? Yeah, because it would reduce my overall costs. But would I choose apartment C over apartment B? No, because it would increase my marginal cost by $20. So it's always kind of comparing to the one that's right before it. You could do it the other way and compare to the original one and look at differences, but this is probably the easier way to think about it. So this idea of marginal we'll use a lot, and it won't always be just marginal cost, it might be marginal benefits, right? So if I choose to do something, what are the additional benefits as well, right? But this idea of marginal will come up a lot, okay? So marginal benefits, would be, what are the additional benefits from choosing a certain option? If I had two job offers, if I take job offer one, it's $50,000 in salary, and then job two is $60,000 in salary, right? The additional benefits from choosing job two would be additional $10,000, right? Going from $50,000 to $60,000. So once again, this idea of marginal is always not just like what the total benefits are, but what are the additional benefits by choosing to take that second job relative to the first one? Or maybe, kind of giving a precursor, I think I'll burn an example here. We got in time. What we can think about as I buy more of something, the additional benefits might change. So for instance, if I buy a car, going from not having a car to having a car, the additional benefit is huge, right? I can get to work, I can get around, right? It's a huge value to going from 0 to 1 car. But if I buy a second car, what's the additional benefit of that? What's the marginal benefit? Well, maybe if I'm a family, we've got multiple cars now, there might be some benefit, but if I'm only one person, to really highlight this example, when I go from one car to two cars, I can only drive one of them at a time, right? The real value came from having that first car. Now, I might like the second car, and maybe it's a nicer car. It's kind of a, maybe got a Jeep to drive around in the summer, and kind of, there's some additional benefit to that, but it's not near as beneficial as going from 0 to 1 cars, right? So sometimes in adding units, we see that the marginal benefit kind of decreases. This kind of will work us into the law of demand here eventually. So another good example of thinking about marginal benefits and how we can calculate them is maybe a question like, what's the value of a view? So I grew up in Southwest Michigan, and they have like these condos, and they're pretty big, and they would overlook the lake. And so that means you've got this building, some of the condos are viewing the lake, the ones on the other side, you're looking at the city, right? And so what do you think, which of those do you think has a higher rental rate? Or if they're selling the condos, how much would they, which ones would sell for more? The ones that have a view of the lake, that overlook the lake, right? And people will pay, and in fact, there's streets where there'll be like a road that runs on a lake, there's property on one side, property on the other. You look at home prices, the ones that are on the side of the road that's not next to the lake, dramatically lower. I mean, I'm talking like hundreds of thousands of dollars, right? And so we can actually put a value on what the benefit of having that lake view is. How can we do that? Well, we could look at kind of the home prices of comparable houses that are on the lakeside versus those that are just on the other side of the road. If I'm using the condo example, how much are the condos selling for that have a view of the lake versus the condos in that same building, same amenities, same flooring that put on the other side, right? And the difference between those prices will tell us, well, that's how much people must be benefiting. If they're willing to pay that extra amount, that must be how much they benefit. So this idea of marginal benefit, we also think about it as a willingness to pay. I am willing to pay up to X amount of dollars if the additional benefit I get is at least that much, right? Like, let's say I value a view of the lake $100,000 every year, like that. If over the whole year, that's how much I would pay to have a view of the lake. Well, then I'd be willing, that's my marginal benefit of having that lakefront condo versus the other one. Well, then I pay an additional $50,000 for it. Because the marginal benefit of $100,000 greater than the additional cost. Well, then I start looking at actually the additional cost is $80,000 to live on that lakeside. Well, the benefit, the additional benefit of having it to me is $100,000. The benefit's still greater than that additional $80,000 in cost. I'll still choose that or buy that lakefront condo. Well, what if the cost becomes $120,000 more to have that lakefront condo? Well, my marginal benefit is $100,000. The additional cost is $120,000. The costs are now greater than benefits, and I won't choose to purchase that condo that's on the lakefront side. And so we're really there. We're just, our marginal benefits is we'll be willing to pay up to this amount, right? We'll incur additional costs up to whatever the additional benefits I'm receiving are. But once it pushes past that point, I'm no longer decide to buy that condo, buy that good, whatever. Okay. Some other questions, what are the marginal benefit of choosing a certain instructor? So, I don't know, maybe negative. I don't know, if I'm not as good of a teacher as whoever else is teaching 201, well, then you choosing to have me as your instructor, actually the additional benefit would be negative. I wasn't as good of a teacher as those other professors you could show. Hopefully that's not the case. Hopefully it's strongly positive. All right. But there we're just comparing. I chose this instructor. What's the additional benefits relative to choosing those? Then the example that we'll start building kind of our law of demand, law of supply, kind of discussing some of those things is this idea. I already alluded to it with the car example, but I'll use the marginal benefits of consuming beer. Right. So this is like at least how I view it. Right. So I've got how many beers I'm consuming on this x-axis, right? And I can think about, I'm going to measure the marginal benefit consuming each additional beer. So we start out at 0, there's nothing there, right? I'm not consuming, there's no additional benefit. So I then have one beer. You know, I always use the example, whenever I mow the lawn, I could start a terrible habit, and I don't know why I like this, but if I mow the lawn on a hot day, if I have an ice cold beer right afterwards, it's like I would pay $20. So if someone like walked up to me and was like, hey, Robert, yeah, I would pay a ton, right? Like, so I try to keep a bar all the way up there, but I might pay $20. That's my additional benefit. I would pay up to that amount, right? And then, you know, I finished the first beer and the person said, I got a second one in the cooler. I'm like, that still sounds pretty good. You know, I don't think I'd give you quite as much for it. If you gave it to me for a cheaper price, I'd pay you up to 10, right? Because that would really be refreshing. Well, then they're like, okay, I got a third one. And I'm like, well, I mean, at this point, it's like, you know, it's still 5, 6 o'clock. I still have things I need to do tonight. Like, I might not pay you, but you know, if you gave it to me for, I don't know, $4, maybe I'd buy that third, right? And eventually it gets down to a point where each additional beer, my marginal benefit is going to be getting lower and lower. We won't look at examples like this, but the beer one I always say, you know, I'll get up to 10, you know, maybe I'm down here at negative, right? Marginal benefit. But that's the idea. I always say it's kind of a stupid example, but it helps you remember as I consume more of a good, generally that marginal benefit, we were kind of to connect the dots here, right, is declining. Yeah.
Okay, but in the beer example, if you look at the opportunity cost of the beer, you're getting drunk, so you're gonna pay.
Well, right, this, we have to factor in the optimal amount, right? Because we have just said I'd be willing to pay up to this amount. If you told me beer is free, and the cost is 0, well, as long as the market is positive, I'll keep it, right? But if you told me that I'd pay up to $20, but if you told me the price of this ice cold beer is $50 a beer, I'm not gonna drink any beer, right? So this is just understanding the marginal benefits. To make the optimal decision, you're like jumping the gun a little bit. You're good, you're thinking about it right. You then have to look at the marginal benefits relative to the marginal cost. Yeah, so I'm glad you're following with me. That was good. But I don't know, as the example I always use, the car one's probably better because you do get like a dramatic decrease in marginal benefit, but you know. So kind of already jumped the gun. Let's say I did have some kind of marginal benefit, and maybe this is, you know, how much I paid for each beer. So I think the numbers are a little different than the ones using the board. But the idea would be, well, let's say that every single beer would cost me $3. And now I've got my marginal cost, right? Each time I purchase one more beer, consume one more beer, I have to pay $3 for it. So what's the number of optimal beers do we have after going to one? Well, the marginal cost of the first beer, $3. But I pay up to go up to where that marginal benefit is, I pay $8 for it. Well, the additional benefit is 8, the additional cost is 3, and then I choose to purchase and consume that beer. Yeah. But then, will I have a second beer? Well, the cost is still $3 a beer, right? How much I would pay, or my marginal benefit is $6. The additional benefit is greater than the additional cost, so I consume that beer. I basically consume up to the point where my marginal benefit is greater than, or what we'll say equal to, the marginal cost. So I will consume something, or I'll purchase something, as long as the additional benefit is greater than or equal to the additional cost. So we include that equal to, so like in a situation like this, right? If I could consume, you know, we broke this down in further units, this would be the very last beer that I consume. But we take this example, right? And I guess I could consume like, if I could buy half a beer, maybe I would do that here, right? But I can only buy it like in integers, right? 3 beers, 4 beers, 5 beers. So that third beer, the marginal cost is below the marginal benefit, or the marginal benefit is greater than the marginal cost, so I consume that. And then for the fourth beer, the marginal benefit is now fallen below the marginal cost. So I'm kind of getting less than what I'm having to pay for that beer. So I wouldn't choose to consume that fourth one. So the optimal number of beers in this example would be, all right, I'm going to stop at that third beer. Now, once again, if the cost is 0, notice this just kind of keeps going out. The marginal benefit is greater than the marginal cost of 0 out to whatever quantity goes with that. Questions on this idea before we keep moving? Okay. And you know, you could play around with this, like if marginal benefits change or the marginal cost change. Really, what all we'd be looking for, if we have this on the graph, is just saying, okay, where does my marginal cost intersect that marginal benefit line? And eventually we'll kind of see that this marginal benefit line really is what we will also kind of call demand for a certain product, or in this case, demand for beer. But this is just kind of a different visualization where it has slightly higher marginal benefits. So if somebody had higher marginal benefits consuming beer, then potentially their optimal number of beers, even at that same price of $3, might be a lot higher, right? And this person's, you know, given how much this person values beer, they would consume 10 of them at the price of $3. The person in the previous slide was what, 3? Questions on this idea? And we'll talk a little bit more about how we graph these in a second, or in a second, kind of down the road, probably on Friday. For now, I just want to kind of show you the visualization and kind of think about where those optimal points would be. So we can also think about costs vary across individuals, across countries, across companies. So I'll start the example today, and by the end of class on Friday, we will kind of have talked a little bit about how we can see, given different costs to these individuals, countries, or companies, how trade can be beneficial. But we won't quite be able to complete the example today, but I'll at least set it up. Excuse me. So let's think about, we've got two individuals here. So we've got the CEO of Ford and it's kind of a mechanic that works around wherever the Ford plant is. So maybe the CEO of Ford, you know, grew up and had a dad who taught him how to work on cars. He's very good at it, right? And so he could fix his car, if something's wrong with it, he'd fix it in 30 minutes. But the mechanic, you know, pretty good mechanic, but not as expert as I guess the CEO was, they can only fix it in an hour, and they charge $150, right? So when we look at this, you might think, well, who should be fixing this car? Well, the CEO can fix it quicker, right, in less time. And if time is valuable, then maybe it would make us think the CEO. But that CEO's time being very valuable means that when he gives up those 30 minutes to fix his car, he might be foregoing really, really high wages, right? And so let's say by fixing his own car, that 30 minutes, he could have made, I don't know, $1,000. Well, then if he would have paid the mechanic to fix it and just spent 150, his additional cost, 150, wouldn't be as great as the additional benefits of choosing to let the mechanic do it. Because if he lets the mechanic do it, the additional benefits to the CEO is that he can work and make an additional $1,000, right? So his marginal benefit to letting the mechanic fix his car is $1,000. The additional costs are 150. He's still kind of net, right, positive $850. And so if we factor in the value of time, just because someone can do something better, right, the CEO can fix this car in less amount of time, doesn't mean it's necessarily optimal, right? Because we have what we call not just an absolute advantage, right, but comparative advantages matter. And comparative advantages are how costly is it for each one of these people to fix the car. So we can think about here, you know, let's say instead of $1,000, it gives you an actual number. So let's say, you know, his time is valued at $2,500 an hour. That means that he fixes his own car for 30 minutes. He's, you know, giving up, $1,250. So that additional benefit of letting the mechanics fix his car, right? How much money he'll be making that work, you know, as a CEO as opposed to fixing his own car. That additional benefit much greater than the additional cost the mechanic is charged. Okay. Any questions on this idea so far? So we've got kind of two terms here. One is absolute advantage, the other is comparative advantage. So absolute advantage means that if someone's producing something, right? So we're going to change the context to go from like CEO mechanic to two countries producing different goods. So if you have an absolute advantage, it means that using all your resources, you can produce more of a certain good than the other country. Or in our example, who had the absolute advantage in fixing the car? Well, the CEO did. He could fix it in a shorter amount of time, 30 minutes versus an hour. But who had the comparative advantage, right, in fixing this car? Well, the mechanic, although it takes them longer to fix it, right, it's way less costly for them to work on it for an hour than it would be for the CEO to spend 30 minutes on working on his car, right? Because his time or her time would be highly valued, right? So we've got absolute advantage. The CEO could do it, using all the resources, could fix the car in less amount of time. Absolute advantage. But the comparative advantage was with the mechanic, right? Because time was so costly for that CEO, right? What the CEO should be doing is instead of fixing cars, they have a comparative advantage in running the company, right? So this is the idea of kind of absolute and then comparative advantage. I said I'll kind of transition this to be a country example. So let's think about Brazil and the United States. I just chose some, I don't know why I chose Brazil, but let's say they were all producing jet, right? So if they took all their resources for kind of, I don't want to say automobile construction, but construction of traveling devices, jets or versus cars or versus automobiles, that if they're taking all their resources and producing jets, we've got the following, right? So if they produce only large jets, and they use all the resources, the US could produce 30 large jets. If they instead took all those resources and produced smaller jets, they could get 40 smaller jets. That kind of makes sense, right? Like given all my resources, all my metal, all my workers, right, I can produce more small jets from using all my resources than I could large jets. And then Brazil has some idea if they use all their resources, they can only produce 10 large jets. But if they use all their resources, they could produce 30 small jets. So here we think about who has the absolute advantage in large jet production. Well, absolute advantage just means using all the resources, they can produce more. So the United States, using all the resources, can produce more large jets than Brazil. We would say they have an absolute advantage in large jet production. We look at small jets. The United States, using all their resources, can produce more small jets than Brazil. So here we have an example where the US has an absolute advantage in both large and small jet production. But that doesn't mean they have a comparative advantage in both. Because the trade-off is, I had everything set up here with using all their resources. So what if the United States starts to take some of the resources and instead of producing large jets, maybe they want to do a combination of some large jets, some small jets. The cost of producing a small jet would be however many large jets I have to not produce. Because I'm now taking some of my resources to produce large jets, and I'm putting it towards producing small jets. So I'm no longer able to make as many as I did large jets as I did before. Right? There's a trade-off there. There's a cost to the United States to start producing small jets, and that cost can be put in terms of how many large jets I'm no longer producing. And we can do the same thing for Brazil, right? So once we come up with those costs, who should be producing small jets? Well, whatever country has the lower cost, right? Whoever has to forego fewer large jets by producing the small jets, right? So we'll kind of talk about how we calculate these costs given kind of a setup like this, starting next class. So once we have those costs of production, we can start to talk about not just absolute advantage, but comparative advantage, right? And that might not always be kind of, but not like those two things might always line up. So get on, make sure you get those iClickers registered. I can see quite a few of you have done that. I'll probably go through like a dry run sample iClicker question on Friday. It won't be for points. We'll start using for points on Monday. Get on, get registered for the online board. My ECON lab, if you're having any issues, like I said, I think they should be resolved, but feel free to reach out to me. Other than that, I'll see you guys on Friday. So you can register. Yeah. Yeah, so there's an app called iClicker Student. You can download.
Is it that one or?
Yep.
Yeah. I got it and I thought it was something, I'm not sure what it was, but it didn't give me a number, but it was registered. So I was so, and I'm like, across,
Go back.
to this.
back into the app, so. Go up to here. Go to profile. Register.
Then I don't actually have. So I need to.
Yeah, go back, and then like in our settings. Down there. You may not. need to since you registered.
I would figure since I was already registered.
I think it'll already link it up. Yeah.
But I didn't register in Kansas because I didn't have the.
Yeah. Let's keep track of Friday's dry run, so make sure hopefully you're here and you can use it. I should automatically be able to kind of sync up your name.
Okay.
I thought for some reason it still gave you a number somewhere, but I don't.
Yeah, I'm not
where it's.
I'm not seeing it.
They changed it a little bit. It used to be called Reef. And so it operated,